we now continue our quest for the organic chemistry Holy Grail? The Holy Grail, as you've probably picked up by now, is follow the recipe, follow the rules. It's all the IU pack that we have to just keep plowing through. Now, let's have a look. Now, let's recap very quickly where we are, because we've now on number 4, so we've had 3 sections. So first of all, we had an alkane, okay, which is a CC. Then we had an alkene, which was a C double bond C. Then we had an alkyne, which was C triple bond C. We're just going through the functional groups. Okay, in other words, the families. Then we had an alkanol. Oops, sorry. Before that, we had a haloalkane. Remember him? Haloalkane, which means we had a CCC, and we added in there either a fluorine, a chlorine, a bromine -1, an iodine, and that was fluoro, chloro, bromo, iodose, right? And if there was 2, it was difluoro, dichloro, trifluoro, trichloro, right? That was the haloalkane family. Then we had the next one, was where we said we have the alcohol. All right. What did we add? We added an OH. Once again, it's a -1, so we have a CC and we have a plus, and you have the -OH forming CCC with an OH bond over there. That is an alcohol, and what do we call it? Okay, it's an alkanol, and it is 1, 2, 3 meth propanol. Okay, if we had in between, if the OH was there, for example, let's just do it separately. Remember, we said CCC and the OH was here. 1, 2, 3. It's symmetrical, so it doesn't matter. So it's propan 2-ol. Correct? That's how we did it. Hexan 3-ol means the ol is on there. And if we had 2, it would be a diol or a triol. So those have gone through now. The next thing that we can add to a carbon is, what about carbon plus an oxygen? Okay? It's not a chemical reaction at this stage. We're going to put a carbon. Let me not put it in that form. We're going to plus an oxygen. Now, a carbon, we said, was like that, right? Our oxygen is a -2, which means that the oxygen holds out an electron. It holds out 2 bays, which means when the carbon joins it, okay, let me just make this look better. When the carbon joins it, this one goes to here, and this one goes there. Because remember, in each stripe there's 2 electrons. So there the H joins up. So there's a double bond oxygen, right? So the next groups we're looking at are carbon, okay, double bond. Why? Because it's -2. Double bond to oxygen. Now, you can have this, double bond oxygen there, and we fill that in normal like that, and you can, but hold on, well, we've also got to consider the possibility of this as well. We can also have the same thing, but we can have a double bond oxygen there, like that, right? Now, if it's in the middle, this is called a ketone. So our suffix, our family, is an -one, right? Now we're going to say 1, 2, 3, meth-eth, it's prop, okay? So it's prop. This is also called a carbonyl. Carbonyl. What's the one above called? Carbonyl. Carbonyl. and this is called an aldehyde. Aldehyde. Okay? So how do we know? Our suffix over here is going to be Al. All right? So over here we've got 1, 2, 3, meth, eth, prop. This is going to be propanal. Okay? Propanal. Okay? Propanal. Right? And this one is going to be, it's a ketopropanone. All right? Hexanal, propanone. Propanone. Because it's a ketone, propanone. All right? Because you can't have propaone. So they put an N in it to make it read right by assumption. Okay? Now, as we said previously, a lot of these you might get one. They're not normally heavily asked at this level, but let's just go through them in the key. Let's just go through here and we say, all right, here's an example of one. We've got a C, C, C. We've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 there. And we've got a double bond O with an H there. And we've got down here a C and a C. Okay? Oh, of course, you can have a dione as well, huh? 2 ones, right? All right, so let's have a look. So this is, first of all, let's see. Okay? Its family is going to be it's a double bond O, all right? So at the end, all right, what are we going to have? This is an al at the end, okay? Al, nal, whichever way, hexan, al. It's an al. Let's leave it as an al. Okay? Let's leave the suffix as an al, all right? And we'll put it in. So say, right, now let's find the longest chain. We first found the family, the series, right? The functional group. Then we say, right, green, longest carbon chain is actually that. All right? And we label always 1, 2, 3, 4, 5, 6. So this is an al. Carbons, we said count them now. First of all is the family. In other words, the functional group is an al. It's an aldehyde. Okay? In this case, an aldehyde. So it's an al. It's always an al is on 1 because it's at the end. Okay? Sorry, I should have put that. Carbon double bond aldehyde is, let me put it in red so you can remember, double bond O, always at the end. Okay? For an aldehyde, it's always at the end. Ketone can be anywhere in the middle. Okay? Let us continue with this example then. Now, we say we've got that one. We've labeled it. So therefore, 2 is label and count carbon. So I've got 6. So therefore, it's a hex. And I know it's an al. So it's going to be hexanal. Right? And it's single bonds in between. We're not going to deal with any doubles here. The last part is, remember, we have got a CH3 stuck out there on number 4. So find the side chains. There they are. So we make a list of sides. Okay. On 4, we've got a methyl. So therefore, it's going to be 4 methyl hexanal. Very, very easy to do these. Okay, so we've got that. All right. Now, let's have a look, and we've say, for example, let's put another side chain on this guy over here. All right. Let me go back. Put it on black. Let's put another one on. Let's put a CH3 there. All right. Okay. Now I've changed it. It's not the same one. I've now got. It's going to be 2,4-dimethyl, right? It still stays hexanol, all right? But it now becomes another side chain of a blue. Let me put it on. Can you see? There's another one. So it becomes 2,4-dimethyl hexanal. Okay? Therein lies the solution to the problem. Okay, we've got those. Let's look at a different one. Here we go. Okay, just move that right out the way so it's not haunting us. Let's look at this one. I've got a C up here, and 2 down here, 2 down there like that. And then I've got 1, 2, 3 leading away. 1, 2, 3. And over here I've got a double bond O, and I've got a C there and a C there. Right. Okay. Now, I say step 1. Right? Obviously, these have all got their hydrogens on them. All right. And this one has got nothing, correct? Because it's there. So once again, step 1 is functional group or the family name. And in this case, it's going to be read. We identify a double bond O in the, or let me say, double bond O, not at end. Therefore, it's a ketone family own. Okay? Now then, the next thing is to say identify the longest structure. And there it is yet again. All right? What do I do here? All right? I now say to myself, okay, I have got the longest, Amelia always complains about that. I have got the longest chain, and I number from the end closest to my functional group. 1, 2, 3, 4, 5, 6. If I'd have numbered the opposite way, I'd go 1, 2, 3, 4. It means it's one more. I always get it the shortest. So therefore, on there, I've got longest chain is going to be 6. Therefore, hex. So therefore, it's a hexanone. Okay, hexanone. But hang on, where is it? Because I have to say where it is now. So I can't just say hexanone. I've got to say it's a hex. And where is it? 3-one. Okay? Always when you've got a ketone, your oxygen double bond O is not at the end. It's in the middle, so you must tell me where it is. Remember the alcohols, they could be in the middle. You've got to tell them where it is. So this tells me where my own actually is. Remember, this here is the own. If I had 2 of them, dione, trione, I can have a dione, trione. All right, in case you see it, highly unlikely, but there you go. Okay. Now, next I've got to find the side chains because I haven't finished. Whoops. I haven't finished yet. I've got the side chains to go. And here we go. Okay, where are you? Blue is a side chain. There's one, and there's one. If you do it this way, you don't miss anybody, right? And therefore, what do I have? Oh, now I list my side chains. On 4, I've got a methyl. So I list my sides. On 4, I have a methyl. And on 4, I have another methyl. So therefore, we've got 2 methyls. So it's going to be 4,4-dimethyl hexa 3-one. Okay? Because it's an anion, hexa 3-one. All right? Okay? Okay. We must always say, yep, we've dealt with that. Okay. Now, the next functional groups are the ones that we're going to do more work with. Okay? The next functional groups that we're going to talk about are what is called carboxylic acids. Okay? Carboxylic acids. And they generally are a chain of carbons. And at the end of them, we've got an structure that looks like that. OH, double bond O. Can you see the double bond O coming in from the aldehyde and the OH from the alcohol? Don't even think like that. Don't try and put them back to where they may have come from. Just say to yourself, this is a new group, all right? And its family is that, and I always remember them as COOHs. They are acids, right? It's an acid. So how do we go further with these guys, right? But basically, the acid is always ending like this. Okay? So it can't be in the middle. It's always ending like that. So we've got an carboxylic acid, and the family name is oic. Oic. It's an oic and acid. Okay? So this one, we say, right, can you note they've got single bonds still? So I say, right, this is all like that. I found the name, I found it. The family is an acid. It's a carboxylic acid, and its name is oic. I now have to give it a name to see what kind of acid it is. And essentially, I'm going to look and say, longest chain, always, there it is. Labeled 1, 2, 3, and 4, because we label from the end nearest the functional group. And the functional group was the acid, always at the end or beginning, right? Can you see I labeled that way? So therefore, what's this? Meth, eth, prop, but. So we call this butanoic acid. And you've never got anything in the middle, so that is straightforward butanoic acid. Okay? Straightforward. These are very, very simple, all right? They're easy examples because all they do is they say, all right, draw hexanoic acid. So, all right, hexanoic acid. Step 1, they've given me the functional group. So I know that I've got a double bond. Let me draw it the opposite way, just to confuse myself and everybody. I've got an OH, a C double bond O. And they've said hexanoic. This already tells me what? This tells me that this is an oic that I'm drawing, because it always ends like that. Okay, black. And now we say, right, hexa, it means 6. 1, 2, 3, 4, 5, 6, and boom, boom. There we go. That is hexanoic acid. Not complicated whatsoever, is it? So the acids are actually very simple. What we've got is a double bond O and an OH on the end, and 1, 2, 3, 4, 5, 6. So this becomes hexanoic acid. Okay? And while we're talking about acids, all right, we'll get to the next functional group now. While we're talking about acids, okay, my question to you is this, okay? What defines an acid? What defines an acid, guys? Let's take the acids that we know. HCl, H2SO4, H3PO4, HNO3. What has this got in common with that? This, I said, is an acid, right? It's carboxylic acid. The secret defines an acid is this guy, isn't it? An acid is a proton donor. So what does that mean? It gives away a proton. What's a proton? It's an H+. The simplest proton is H+, a single proton. So when we put HCl in water, what happens is the H moves away. It gets given off, right? Now, therefore, when we put the acid, we have to say to ourselves, okay, We're now speaking about these as acids. So where's the H? Well, let's just quickly go and do an example with this. Okay, I'm just going to keep it, if you will forgive me, I'm just going to keep it into simple. I'm just going to say meth eth prop. Let's call propanoic acid. We say CCC, meth eth prop. Okay, double bond O, OH. That is propanoic acid. Correct? Like that. The next step with propanoic acid is to say, right, now I am going to form the acid portion. So the hydrogen gets given off. Well, which hydrogen gets given off, guys? Actually, it's this one. Anybody want to guess? Whoops, sorry, there's nothing there. It's there. I'll come back to that. So the hydrogen that gets given off, all right, I've now stuck this in water and I've got an H+. H+ is unstable. So the H+ links up with an H2O to form H3O+, the hydronium ion, correct? That's an ion. Whoa, hold on. What's it left behind? Technically, okay, this is what's sitting there, isn't it? Okay, technically, what it's left behind is a stick, because this O over here, this O and that H were bonded to the C, right? There it is. I've just enlarged the carboxylic acid portion. I've actually got an electron sharing there and an electron sharing there because oxygen's got 2, right? So when I remove the proton, I've got this O, C, E, E, balanced, and I've got an electron now sitting over here with no one to share. So it becomes -1. So we have created an ion. Oops. Okay, I have created an ion when we do this. We put it in water, same as HCl in water. So we've got CCC, I think we had that, double bond O, and an O over here. This is actually a propanoate ion. Okay, that reminds me, I need to still do alcohols. I must still do the alcohol, the simple and the primary, secondary, tertiary alcohols. Propanoate ion, okay, and H3O. Here is the acid portion, and that forms the conjugate base, but we'll get to that soon. This is the propanoate ion, okay? So the propanoic acid, see, Kevin did it again, put a stick there. Propanoate ion, meth eth prop, 3 carbons, it's an ion. Why is it an ion? Because it is charged. It's -1, right? So now, the next step to consider, any of the acids we put in water, it loses the H and it leaves this O with a flopping arm. Remember that. Now the next step is we're going to see the last functional group that we're going to deal with is the ester. Okay, the ester, right? The ester has got a carbon chain and it is characterized by a double bond O, single bond O, and a C. It has got 2 chains. All right, so we look for that group there. That is an ester and it is an O8. All right. Yes, it comes from the propanoate ion. That we're going to do when we talk about esterification, the actual process undertaken by the propanoic acid when we're mixing it with an alcohol, actually. So let's say, right, we've got that. This is a different side. This is now the side chain here. All right. The orientation must be, this is the defining place here, guys. the red. This is the defining place, right? If it was O, C, well, let me just do it in black. Let's say, in fact, let me leave that as an example. There's a side chain here, all right, blue. This is our side, okay? This is the main chain. It must be in that order. Double bond O and an O next to it, right? So now let's have a look at what these look like. This form is like this. Let's say we've got a CCC and we've got an O, C, double bond O, C, 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 C. All right? Whoops. Oxygen. Yep. Like so. Okay. Oxygen double bond. 1, 2, 3. 1, 2. Oops. Sorry. Just see, I do this too quickly. Okay. And we've got now like so, like so, like so, like so, like so. Right. Now what do I look for? I look for, I've been given this and I've asked what it is. Aha. Can you see, therefore, I've got that way. Therefore, this is the O8. Okay, the functional group is an O8. And now I must identify its chain. Its chain goes that direction because the O and the double bond O must be in that orientation. Okay, so therefore, this is 1, 2, 3, 1, 2, 3, 4, 5. Meth, eth, prop, bute. This is a butanoate. Okay, by now you should be getting used to the fact that you can write straight butanoate. Then the sides, okay, and with these you only have to worry about it like that. The side is what's on it. 1, 2, 3, meth, eth, propyl. So it's a propyl butanoate. Okay, propyl butanoate. Take that away. Propyl butanoate. Meth, eth, prop. This is a propyl. It's a side. It's a side chain. Okay? It's a side chain on its own, right? Okay? Now, this is quite straightforward and quite simple to do, right? So if they give us something, we say, all right, let's just say they give us this and they ask us to name this, right? They've given us here CH3, CH2, CH3, CH2. I can just leave it in blue. CH2, okay, C double bond O, O, and then CH2, CH3. Right. How do I identify it? You can go straight to source and do it if you wish. However, I like to say, hang on, let's just draw this character first, just to make sure. C with 3 H's, linked to a C with 2 H's, linked to a C with 2 H's, linked to a C with a double bond O and an O, a C and a C, like so. Then I say, right, let me identify my group. There she is. This is an O8. Okay, so I already know it's an O8. Find my green chain. There it is. Okay, that's the way it must be. That's the orientation. 1, 2, 3, 4. 4 carbons, meth, eth, prop, bute. So this is a butanoate. Okay, all right, it's a butanoate. All right, let me just check 4. Okay, butanoate. And what is on it? My side chain, the blue guy, is meth, eth. So it is ethyl butanoate. This is an ethyl. So my side is an ethyl. So in this case, I can just go ahead and write it. And I can say this is ethyl butanoate. All right. Okay, let's just have another one just for practice. Okay. Let's see, they've got this. This one. C, 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 O, C, double bond, what? 3. Okay, so I've got, now I'm putting these in All right, 1, 2, 3, 4, like that, right? Now, what's my first step? First step is find the functional group. There it is. Orientation tells me my green is to the left. Oh, sorry, to the right. Because why? The O and the double bond O indicate the direction that way. So this red tells me that it's an O8. Meth eth prop, so it's a propanoate, right? Propanoate. Okay? Propanoate. And my side chain is the piece that's left. And what piece is left? And it's meth eth prop, so it's a propyl. Propyl propanoate, or propyl propanoate, whichever way you want to see it. Okay, we're also going to look at the we're going to look at formations of esters, some cyclic structures later, all right? And alcohols I'm going to look at. There is some later coming, more alcohols. Okay, right. So we've now gone through the main functional groups. I'll recap in the next one. Cheers, have a good one, and good luck with it. Remember, always go back and look at the answers and then look where you went wrong on them. Most of the books today at our levels have got answers in them. Find the mistake. Don't just go, I don't know. Family name first, whatever it is. Da, 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 da. Cheers. Bye.